Hi, welcome to the CHEMBLAST video series. In this video, we're going to discuss on question 1 of chapter 2, atomic structure. Now let's start with question 1a, part 1. Name this series of hydrogen emission spectrum. So this is a series of lines, and they tell us it is in the visible region. Now, first of all, let's look at how to name this series. So this is visible region. So how many series we have? We have Lyman series, we have Balmer series, and we have Bastian, bracket, and P1. Now, which series actually is found in the visible region? Yes, it is the Balmer series. So the answer is Balmer series. Now for this question, 1a part 2, state the electron transition that produces line C. Now, first of all, what is the meaning of transition? Transition means movement. And which line are we interested in? We are interested in line C. So line A is actually the first line in the series because it has the furthest distance. Line B is the second line, and hence line C will be the third line of this Balmer series. Now, how are we going to get the answer for this? In order to get the line C, we know the electron will always drop from a higher energy level to n equal to 2 because all Balmer series will have electron falls back to n equal to 2. So the first line of Balmer, actually we have electron dropping from n equal to 3 to n equal to 2. The second line, we have electron drop from n equal to 4 to n equal to 2. And because the question asks for line C is the next line where electron drop from n equal to 5 to n equal to 2. So the answer is this. Now let's look at question 1a, part 3. Explain the formation of line A. So this is line A, which is the first line of Balmer series. So they ask us to explain. Okay. Now how are we going to answer this question? So for line A, which is the first line of Balmer series, we should know that electron will all drop to 2 and first line, so it comes from n equal to 3. So before it comes to n equal to 3, we have to explain what happened initially. So before anything happened, electron is always at the ground state. And what happens is when the electron at the ground state absorb energy, they will get excited. They will have more energy. They will go up to n equal to 3, which is the electron that we are going to explain now. This is why it goes to n equal to 3. And what happened at this energy level? When electron has very high energy, it is called excited. And it is very unstable here because high energy will make you very unstable. So you cannot be here for long. So what happened to this electron? This electron will try to drop to n equal to 2 by releasing energy in the form of photon. Photon is light, and you will see a line that is corresponding to line A. You got it? Now for question 1b, it states here, a set of quantum numbers for the highest energy electron in J atom is given with this set of quantum number. The question asks us to write the electronic configuration for J atom. Now how to answer this question? So we are given one set of quantum numbers, 300, positive half. So this is N, L, M, and S. And they tell us this is the highest energy electron that we have. Now, remember, one set of quantum numbers that made up of NLMS actually represent one electron in the atom. And this electron is actually at the outermost shell because it has the highest energy. The further an electron from a nucleus, it will be having higher and higher energy. Now, where is this electron? So we can see from here, the N and L will tell us the orbitals. Okay, so N equal to 3, meaning that it is in shell number 3. L equal to 0. It tells us this is orbital S. So combining these two information, we know that this electron is actually located in orbital 3s. 3s is having one orbital, and because you only have one set of quantum number, it is one electron that is at the highest energy level, the outermost shell. So 3s is the furthest. So we have learned that before 3s, we have our orbitals with lower energy, which start from 1s, next is 2s, and then the next one is 2p, followed by 3s. And because there is only one electron here, so we will write 1 here, and the rest must be fully filled, because according to our Fock principle, we must fill up all these lower energy level before we can get to the orbital with higher energy. So how to fill up 1s? 1s has also maximum 2 electrons, so we can put in 2 here, and this 2s also 2. 2p, p is having 3 types of orbital, px, py, pz. So each of them can fit 2 electrons maximum. So total electron that we can put in is 6 electrons. So we put here 6. So the answer is the configuration of J is 1s2, 2s2, 2p6, and 3s1. Now let's look at the next question, 1b, part 2. Draw the shape of the orbital for the valence electron of atom J. So this is actually the valence electron of atom J. Now how to answer this question? The first thing we need to know is that the shape of orbital is determined by the azimuthal quantum number L. This number L equal to 0. So we need to draw the shape of this orbital because this is the valence electron of atom J, which we have seen just now. It is in orbital 3s. So this is the configuration of atom J, and this is the valence electron. And S orbital has a shape of spherical. So we draw something like a ball, and then we shade it, and make sure we put in the axis X, Y, and Z, and label the orbital, which is 3s. Now the last question, 1b part 3. what is the most stable ion formed by J atom? And draw the orbital diagram for J ion. Now, how are we going to answer this question? So the first thing we know, we will try to look at the configuration of J atom again, and we can see that this is the valence electron. So how are we going to be stable? So if you have something like a noble gas, which has 8 valence electron at the outermost shell, you will be very stable like the noble gas. So do you think J would donate this 1 valence electron, or J will try to accept 7 electron in order to become 8 valence electron? So it is easier to donate 1 electron. Therefore, J will not accept 7 electron to become 7 minus. It will donate 1 electron to become 1 positive. Because of this, the stable ion, most stable ion formed by J atom is J positive. Now, how to draw orbital diagram? What is orbital diagram? Orbital diagram is boxes. One box to represent one orbital. So we have to draw all these orbitals here using boxes and arrows. Arrows, full arrow is to present electron in the orbitals. So this is the orbital diagram. And remember, please use a full headed arrow for all the electrons here. That's all from us, and I hope you learned something from this video. Thank you very much.